All right, you guys, welcome to Algebra 2B for Apex. If you don't know me, if you're just starting out, welcome. Don't forget that I'm here for you. Just email me anytime. I promise I will respond back quickly as I can. During the week, it's about every 2 to 4 hours, sometimes a little bit more often, but never less often. On the weekends, it's going to be about every 6 to 8 hours. So don't freak out if you email me and then it's been an hour and I still haven't responded yet. Just give me a little bit more time. I got a lot going on too. But as we go through this stuff, you guys should be able to pull up the PDF files so that you can follow along if you want to, or just watch the video, take some notes. I would highly suggest you take the notes so that way it gets in your brain better. And then also another good thing is to pause the video before, say I'm pulling up a problem that I'm about to do right here. So before I do the problem, try reading the directions or follow the same directions. If I go on to a part B, it'll be the same directions if it's in that same part. And try the problem. Try the problem first, and then you can see what my explanation is and how I'm thinking about the problem. You don't necessarily have to do it like I do every single time, but I'm trying to find the fastest way I possibly can. I've taught math for quite a few years now, so I have a decent, probably better than decent. But anyways, hopefully you guys understand. But again, whatever you don't understand, just let me know. Ask me a question, and I promise we can even meet. We can do a Zoom session, do a one-on-one video conference, and talk about anything you guys want to talk about. Moral of the story, I'm here for you guys, so just let me know what I can do to help you out. All right, let's get going. Stop wasting time. Let's talk for 2 minutes. So in this first section, we're going to be talking about rational expressions. Rational expressions are essentially just like fractions. They're just called rational expressions because we have an x in the denominator. So 1 over x is a rational expression. Or 2 over 3x to the 5th plus 4. That is also a rational expression. The biggest thing to have a rational expression, we need to have an x in the denominator. Don't forget the denominator is the bottom of the fraction. So that's all that makes a rational expression. So let's kind of start our feet getting a little bit wet. So for this first one, it just says, what is the value of each rational expression when x is equal to -3, 5, and 0? So we'll do 3 cases. We'll do the first one when x is -3. We'll do another one when x is 5. And we'll do the last one when x is 0. All right, so essentially all we're doing is just substitution. It's the same thing as you've been doing. So if we put in -3, that's 12 minus a -3 all over 9 plus a -3. So that will give me 12 minus a -3 is positive 15 over 9 plus -3 is 6, which will reduce, so reduce it if it reduces. So this is the same thing as, since they both divide by 3, 5 over 2. That is what the rational expression is, or what it equals, when x is equal to -3. All right, so now if we do 5, we would have 12 minus 5 over 9 plus 5. So that would be 7 over 14. So 7 over 14, which is 1/2. That's it. That's all you're doing. When I put in 0, that would be 12 minus 0 over 9 plus 0. So that would just be 12 over 9, which will reduce to 4 over 3. That's what it's going to be looking for. All right, we'll do one more of these. So again, I'm still just figuring out the value. Here's a good time whenever you see me do one. Try it on your own and see what you guys come up with. If you make a mistake, at least you tried and you can see what your thinking was and try to correct your thinking. Again, if you guys have any questions, just let me know. I'm here for you. All right, I'm going to do x equals 0 first because I just picked up my purple pen. So 2 times 0 plus 10 over 0 minus 11. So that would be 2 times 0 is 0, plus 10 is 10 over -11, which we will write as -10/11. So it doesn't matter where the negative is in the fraction, it makes the whole fraction negative. All right, so x equals 5. So that would be 2 times 5 plus 10 over 5 minus 11. So that would be 10 plus 10 is 20 over 5 minus 11 is -6. So this will reduce to -10 over 3. Now last one, put in -3. So 2 times -3 plus 10 over -3 minus 11. So that would be -6 plus 10 is 4. -3 minus 11 is -14. So this will reduce to negative 2 over 7. That's it. All right, moving on. So we have, for what value of x does the rational expression equal 0? So now what this is looking for is it saying, when does this expression equal 0? When is that true? For what value of x? What do I put in here such that this whole thing is 0? Well, if we try to solve this like an equation, we can multiply by the denominator, right? X minus 12 times x minus 12. So that makes 1, that would make 0. So I'm left with 9 plus x equals 0. Then it's just a matter of subtracting the 9 from both sides. So x equals negative 9. That's it. That's the value when it's 0. Another way to think about this is if we have something, a rational expression equal to 0, it's 0 over any number. Any number. I don't know if you can hear squeaking. My dogs have decided to start playing. Pups. All right. So 0 over any number, correct? If we have 0 of anything, it's just going to be 0. Now be careful. This cannot be 0, except you cannot divide by 0. Something is called undefined when it's divided by 0. We'll get to this. That's actually going to be the last ones here. But if we're ever dividing by 0, that's when an issue arises. We cannot divide something into 0 parts. It just doesn't make sense. All right, so if I know that the top is going to be 0, what this allows me to do is I can just take that 3x plus 2, and I want to know when that's equal to 0. That's essentially all we're doing, right? We had 9 plus x equals 0 in the last one. Same thing here. So 3x plus 2 equals 0. Subtract the 2, so I have 3x equals negative 2. Divide by 3, so x would be negative 2/3 when the expression is equal to 0. All right, another one, same idea. So when is this expression equal to 0? Well, just looking at the numerator, the number on top, I can say, well, that's when x plus 12 is going to be equal to 0. So just subtract the 12 over, so x equals negative 12. That's when the whole expression is going to be equal to 0. All right, so now this part that I was talking about that we would get to. For what value of x is the rational expression undefined? It's undefined. We can have any number over 0. That is when it is undefined. Right? You cannot divide by 0. So anytime you're dividing by 0, trying to think of a way to explain this. So if I do 4 divided by 2, we know that that is 2 because 2 goes into 4 twice. 2 plus 2, right? 2 plus 2 makes 4. So there are 1, 2 groups of 2. Likewise, let's see, 16 over 2 is 8 because it is 2 plus 2 plus 2 plus 2 plus 2 plus 2. 1, 2, 3, 4, 5, 6, 7, 8. All right, if I add 2 8 times, that gets me to the 16. So that's why it is 1, 2, 3, 4, 5, 6, 7, 8. So now if I think about the case of 0, if I do 2 divided by 0, it's how many times do I add 0 together in order to get to 2? Well, no matter how many times I add 0 to 0, to 0 to 0, right? Infinitely many times. I can go forever and ever and ever and ever. It'll never even get past 0. So since it'll never get there, there is no defined number like 8 or like 2 that I can add 0 in order to get up to the number 2. So that's why it's called undefined. It's not definable. I cannot divide by 0 because 0 goes into something infinitely many times, so there's no definable number that I can give that value. That's why this is called undefined. All right, so knowing that undefined means when we are dividing by 0, I can say if this is undefined for this rational expression, this will be undefined when x minus 12 equals 0, when the whole denominator is equal to 0. All right, so that would be when x is 12. If you don't believe me, check it out. If I put in 12, 9 plus 12 over 12 minus 12, that will give me 21 over 0, which was undefined, right? We were trying to get the 0 in the denominator. That was their big goal there. So x equals 12 is when the function or the rational expression is undefined. All right, looking at another. So again, take your denominator. It is undefined when the denominator is equal to 0. So if I subtract the 7, x equals negative 7 would be when the denominator is equal to 0. Moving on. So now we just have a quadratic. So we would have when x squared minus 16 is equal to 0. Don't forget that'll factor, or you can just move over to 16, which is what I'd probably do. So that x squared equals 16. Take the square root, and don't forget when you take the square root that you need a plus or minus on your solution. So x would be plus or minus 4. Both of those would not work. All right, last one down here. We'll do this one by factoring. So 3 times x squared minus 75. It is undefined when the denominator is equal to 0. So I'll factor out a 3 from both of those, because that's my common term. And then this will factor into x plus 5 and x minus 5. And so now I have my two solutions of x equals negative 5 and x equals 5. Those are both of the x values when the denominator would be equal to 0. All right, that's all I got for you guys today. Please let me know what questions you guys got. Just email me. I'm here for you anytime. All right, I'll talk to you all soon. Bye.